this zeros of the function is going to be a little different, a little trickier. I still have that problem actually hiding out over here. What I'm going to do is I'm going to solve it two different ways for you just right away, and then we'll come up with a new problem, and then you can work on solving that one. Okay, the first way is called factoring. You heard that? And have you heard FOIL? Like distribution, when you do like the front times the front, and then the front times the last, and the last times the front, last times. That FOIL, front, outside, inside, last, is just the opposite direction of factoring. So we're actually going to be turning this equation here into an equivalent equation, but it's going to be in this form. Instead of plus signs separating the terms, we'll have terms inside these two sets of parentheses, and the terms will be multiplied together. There's a reason we do that. It's actually really helpful, because when we're looking for what's called the zeros, what we're really looking for is when the y value, or the function value, is equal to 0. So we just know that f of x is going to be 0. Okay, and just so you can see, we can do a little preview to the next graph here. None of these have zeros shown on them, because do any of these cross down through the x-axis? Not quite. The 0 is when y equals 0. It's not positive, it's not negative. It's when the line crosses the x-axis, because that right there is when y equals 0. Yeah. Okay, and that seems like not very helpful unless you're like doing anything at all ever in engineering. Finding the zeros of functions tells you, or in calculus, it tells you how high up a projectile can get, or the maximum like pressure that a vessel can withstand. Or it typically happens at intersection points on the graphs. Really important information. They're giving you a more abstract problem to work with here, but I promise you, this is super helpful. Again, I'm just going to show it to you one time, and then we'll step through kind of the process. I know I'm going to have an x and an x in front, because when I multiply front times front, what does x times x give me? X squared, right? And we were just talking about that. And that's this term right here. So because I know I'm going to need this term, I know I'm going to have an x times an x in front. So whenever you get a problem that says find the zeros, this is almost always your initial setup. 0 equals two sets of parentheses that are multiplied by each other with x's in front. That's if you have an x squared right there, which you will on high set type problems. Okay. The other one I like to look at is this 24, negative 24. Because when I do my last term times my last term, and if these are each just whole numbers, then the only whole number that's going to show up in my answer here is the product of one whole number with the other whole number. It's like 20% makes sense, but we're going to step through it. Negative 24 can be written using a handful of factors. What two numbers can you multiply together to make 24? There's a couple sets. 12 and 2. That's one of them. One of the sets. What else?
6 and 4.
6 and 4. Exactly. I made it look like 1 and 1, huh? It's not 1. It's supposed to be an arrow. Okay, and there's actually one more common one that we could use.
And 6.
All right, we got that one. You're good. There's a number in between 6 and 12 that also goes into 24.
8.
Yep, 8.
8 times 3.
8 times 3. And technically, 24 and 1 is also a set of factors, right? But here we go. We now have our factors. So no matter which factor I choose, we'll just start with 12 and 2. If I put 12 in here and a 2 in here, and I multiply, again, my front terms are going to give me x squared. That's great. My last terms are going to give me 24. It doesn't matter if I use 12 and 2, 6 and 4, or 8 and 3. I will get 24. But what does matter in picking between these options?
Which one's negative?
That is a very good point. We're definitely going to have to incorporate a negative. One of these is going to be negative and one of these is going to be positive. Maybe it's this way, because we know we're going to have to get negative 24. So that's a really important point, and we're going to come back to that. But another thing that we have to think about is how do we get the 2x? How do we get the 2x? And there's a process for this that will probably become clear when we step back through this in reverse order. But I'm going to give you a little hint for now. The hint is basically you need to be able to make a 2 using a positive and a negative of one of these sets of numbers. So you need to, in any way you can, be able to make a 2 using a 12 and a 2. Now, can you add or subtract 12 and 2 to make a 2? Not quite, right? So that one's out.
6 and 4.
6 and 4. That's, I didn't have to lead you on, right? 6 and 4 can combine to make 2, right? A positive 2. So is it positive 6 minus 4 or negative 6 plus 4?
Negative 4 plus 6.
Negative 4 plus 6. So let me just erase these back. Oops, that's the highlighter. Don't want to highlight. And we'll just do like you just said. How about a negative 4 here and a positive 6 here? Okay. This is what I'm going to do. We're almost to the answer, but in classic teacher fashion, I'm not going to just skip right to the answer because I want to keep talking. Right? Because teachers like to hear themselves talk, huh? You're like, yeah. All right. If I just wanted to check myself really quick, I could just do front, outside, the inside values, and the last values. That's what FOIL stands for. Another way to think about FOIL is just multiply each term by every other term in that set of parentheses. So I'm going to do my x by the x and the negative 4. And then I'm going to do my 6 by the x and the negative 4. So just multiply every term in the first parentheses with every term in the second parentheses. If that helps you remember that, great. Moral of the story is, what is x times x one more time?
X squared.
X squared. What is x times negative 4?
2. No.
It's kind of weird.
Negative 20. Well,
We're just doing negative 4 times x. Negative 4x, right? When we write
6 and 4.
Oh, sorry. I probably pointed in a weird spot. So negative 4 and x makes negative 4x. Because when you write that, what you're actually implying is negative 4 times x.
Yeah.
Which, pretty cool that the answer to negative 4 times x is negative 4 times x.
Yeah.
You can't combine x's and 4's because we don't know the value of x. So we can't push them together quite yet. Now let's do the 6 and the x. What is 6 times x?
6x.
Right, it's positive, right? And then finally, what is 6 times negative 4?
Negative 24.
We better hope so, huh? Because that's how we deduce the 6 and the 4 in the first place. So you see why we were able to figure out that it started with an x and an x, because we got our x squared here. And then we also picked a factors of 24 so that we could make 24. We also knew that there was going to be a plus sign and a minus sign, because multiplying two numbers together, if you want to get a negative answer, you're going to have to multiply a positive by a negative. So far, so good. And now you can really see why we picked the 4 and the 6, because what is positive 6x minus 4x?
2x.
2x. Now, this is me just backtracking, but what's the difference between this and this?
You know how you got that?
Yeah, we kind of, is it different? Or are these two things the same?
It's the same.
They're the same. So all I was showing you was that, I'm just going to take my big eraser here, was that when we factor it, we're doing the opposite of FOIL. you're actually breaking it into factors instead of combining the factors back into some standard form.
Yeah.
Okay? Now, the beautiful thing about this form, why this form is so powerful, is because of one simple thought in math. What is 0 times anything?
0.
0. 0 of anything. 0, phones, $0, 0 tutors. It's 0 of those things. It's always going to be 0. Which means if we can make this equal 0, then it doesn't matter what this over here is equal to, because what is 0 times anything? 0. And then is the equation happy?
Yeah.
Yep. Okay. Or if we can make, what do you think? What am I about to say here? What if we can make this one equal to 0? We can plug in some number for x to make this equal to 0. In fact, you could just probably think of it right now. What number can you plug into x to make this whole term equal to 0?
0.
0 minus 4 would be negative 4. So what number minus 4 equals 0? 4. If we were to plug in a 4 here, we would get 4 minus 4, which is 0. And we'd get 4 plus 6, which is 10. Whatever, it doesn't matter. Because what's 0 times 10?
0.
0. And is our equation happy now? All right. So you actually just found one of the zeros. You did it. Let me erase and write it just a little cleaner here. So
it's negative 6 and 4.
Yeah, you're pretty much onto it here. So we know that x minus 4,
Negative 4.
we want to make x minus 4 equal 0 for one of our answers, and we want to make x plus 6 equal 0 for another one of our answers. Okay, we know that for this one, the answer is x equals 4, and for this one, the answer is
Negative 6.
x equals negative 6. If you wanted to be really fancy about it, you could do that thing that math students do where they subtract 6 from both sides, cancel out, x equals negative 6. Or just use logic. I don't really care either way. And you know what? I know when I'm recording this screen, this is where our video is going to sit, which means that no one's going to be able to see that. So I'm going to hide it over here for a second. Cool. We got our 2 answers. So I can erase this for now. And I'm going to show you one more thing that's going to make you understand visually, which I like. So our 2 answers were x equals 4, comma, negative 6. Let me keep that boxed. If I plug in those values into this equation, I should hopefully still get a 0. I'm going to do one in my head just really quick. Okay, I'll do negative 6. Negative 6 times negative 6 is positive 36. Negative 6 times 2 is negative 12. So 36 minus 12 is 24. And what's 24 minus 24?
0.
0. Great. You can do the 4. What is 4 squared? 8. What is 2 times?
4.
4? Or no, you just said 8.
8.
You had me believing. What is 4 squared? What is 4 times 4?
16.
16. 4 times 4 is 16. What is 2 times 4?
8.
8. What's 16 plus 8? 24. What's 24 minus 24? 0. We got it. Okay. Let me do this really quick, so I don't have to keep going back and forth between screens. And I got this app, but I think my screen will just continue to record. And you know what? I thought I had Decimals, but we're going to go with GeoGebra. It's just as good. We do y equals the equation, which was x squared plus 2x minus 24. Okay. Can you tell me where this graph crosses the x-axis?
Negative 6 and 4.
Crazy, right? That's what you saw. That's what you were solving for. You're essentially given the equation to this graph, and you could have plugged in a million trillion numbers until you plugged in the right one that gave you 0. Or you can unravel the equation and just solve for where the 0 should be by literally forcing your equation to equal 0. And then it solves it for you, and then you don't have to actually graph it. But the graph will coincide with your answer if you did your work right. Or if you were in class and your teacher gave you a worksheet that made you solve 200 of these, you could type in all 200 equations into GeoGebra, and you could be like, okay, there's my first answer, there's my second answer, whatever, right? Technology's great. I'm okay if students use it to quote unquote cheat. Just doing faster math. All right, let me give you one more of these that you can work on. And I promise you, it's not going to settle well the first time because this is one of the harder subjects that students have to learn in school. It's very abstract, a lot of steps to it. And most of the time, students don't even know why they're doing it. So if it takes some time, that's okay.